Hey guys, this is Mr. Grice for Algebra 2, Semester 2 Review, Units 5B and 9. Remember to show all your work, no calculators, and place your final answer on the lines. Number 1 says check if -3, 1, and 3 is a solution to the system. And when we're doing this, remember that these are in alphabetical order, and which one is X, which one is Y, and which one is Z. Okay? So all you have to do is plug in X, plug in your Y, and then plug in Z in the proper spots and check to see if it works. Okay? So let's zoom in. If you need a separate sheet of paper, guys, I would recommend doing that. Okay, so for the first one, we're going to plug in -3, 1, and 3. 5 times -3 is -15. -3 times 1 is -3, plus 12 equals -6. -15 minus 3 is -18. Combine the like terms right there. And then we get -6 equals -6. So for the first one, we're happy. Okay? And now it's time to do it for the next one. Okay, same thing. -3, 1, 3. -3 times -3 is +9, minus 6. And -2 minus 3 is -6. I'm going to combine my like terms right there. And so we have 9 minus 12 equals -3. And then we get -3 equals -3. So 2 in a row so far, guys. We are on a roll. All right, let's plug in -3, 1, and 3. 3 times -3 is -6, minus 7, plus 15 equals 8. Combine your like terms right there. Up, -7. That's supposed to be a 1. I was doing that part in my head already. -7 plus 15, and we get 8 equals 8. So guess what? Since it works in all three situations, that is a yes. All right, solve the system below. Remember, we do A, B, and C. We do A and B, and then we're gonna cancel B and C, and then we can start to figure out what some answers are. Okay, so with A and B, all I'm gonna do is write them down. X plus 2y minus 2z equals 3, and 2x plus y plus 3z equals 1. I'm going to cancel the x's out, so I'm going to multiply this entire top by -2. Okay? And then we get -2x minus 4y plus 4z equals 12. When we combine everything else, we get -3y because 1 minus 4, okay, plus 7z equals, how did I get 12, guys? I gotta pay a little bit more attention. I'm going too quick. -2 times 3 is -6, and we get -5. All right, so we need that one right there. Now we're going to do B and C. So B is 2x plus y plus 3z equals 1. If I want to cancel these two out, what do I need to multiply that by? Okay, hopefully you're saying, by -2, Mr. Grice. Okay, so we got -2x plus 4y minus 2z equals 20. Okay? Combine those up. We get 5y plus 1z equals 21. Okay? And those are the two new equations that we're going to use. So we can go negative 3y plus 7z equals negative 5, and 5y plus 1z equals 21. I think the easiest thing to cancel here would be your y's, which means we have to multiply the top by 5 and the bottom by 3. We're just doing that crisscross where we take the first number. Okay, so multiplying on the top, we get negative 15y plus 35z equals negative 25. And on the bottom, we get 15y plus 3z equals 63. Okay, adding these up, our y's cancel, which is what we wanted, and we get 38z equals 38. And when you divide, those cancel, and we get z equals 1. Okay, now that we know what z is, we can go back to one of our equations in the gray, and I'm going to pick this one right here. So 5y plus 1 times 1 equals 21. We get 5y plus 1 equals 21. Subtract the 1, and y equals 4. So we know what y is, we know what z is. The last thing to do is find out what x is, and that's where we're going to use one of our original equations. And I'm going to go with a. So we have x plus 2, and I'm going to plug in my y, minus 2, and then I'm going to plug in my z, equals 3. So we get x plus 8 minus 2 equals 3. X plus 6 equals 3. Subtract the 6 to both sides, and we get x equals negative 3. So our final answer, we want to put those in alphabetical order, which is negative 3, 4, and 1. Okay? So we did A and B, and then B and C, and remember this was E and this is F. And then we canceled E and F. Okay, and then you work your way backwards. All right, let's go ahead and flip it over, because 4 is one you're doing on your own. Okay, we have to graph the inequality. We have negative 2y minus 4x is less than 8. Add 4x to both sides. We get negative 2y is less than 4x plus 8. And now we have to divide, and we're dividing by negative 2. So we get y minus 2x minus 4, and what did I not do? Oh, I didn't write my inequality because I have to make sure that I flip that. We have to flip it because we divided by negative. Okay? And now we have to ask ourselves, is it solid or dotted? This is dotted because of what symbol it is. And do we shade above or below? And we shade above. Okay? So our slope is negative 2, and our start is 0, negative 4. So negative 4, down 2, over 1, down 2, over 1. Make sure to draw my arrows and make my line dotted. And then we shade everything that is above. There you go. All right. Number 7, another graphing one. Okay, we have x minus 3y less than or equal to negative 12. Subtract the x to the other side. We get negative 3y less than or equal to negative x minus 12. I have to divide by negative 3. And we get y. I just flip this because once again we divided by negative. 1/3 x plus 4. Okay, so our slope is 1/3. Our y-intercept is at 0,4. It's going to be solid because we've got the line underneath it, and we shade above. So I'm starting at 0,4. I go up 1 over 3. Up 1 over 3. Up 1 over 3. And I'm going to do that in both directions. Draw my line, and I'm shading everything that is above. There you go. All right, number 9 says to solve the system by graphing. So now we've got 2 of these that we have to graph. Just make sure we've got enough room to do them both. Okay? So 7x minus 3y is greater than 9. First thing we need to do is to subtract 7x to both sides. And we get negative 3y is greater than negative 7x plus 9. I'm dividing by negative, which means we have to flip the sign. And then we get 7/3 x minus 3. So, things to know. Our slope is 7/3. We have to shade below. Our start point is 0, negative 3, and this is dotted. So I'm going to draw this line right away as I remember all this stuff. We're starting at negative 3. Go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. I know that's off, but we can still kind of tell. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Okay? And this is a dotted line. And just so I know, I'm just going to, that's where I'm going to have to shade. I have to shade below that line. All right, and let's look at our other one. All right, we have x plus 3y is greater than or equal to 15. Guys, I'm going to have to show just a little bit of abbreviated work. We're subtracting the x to the other side, and then I have to divide everything by 3. So negative 1/3 x plus 5. Okay? So our slope is negative 1/3. Our y-intercept is 0,5. It's going to be solid, and we shade above. So I'm starting at 0,5, down 1 over 3, down 1 over 3, down 1 over 3. And I'm going to do this in both directions. Okay? We've got our line. And now I'm supposed to shade above that. The only area that meets both areas is right up in here. So just that small section is our answer. Okay? All right, last one, number 13, or number 11. I'm sorry. Right? Yeah, number 11. Now, we've already got y is greater than or less than -7. Okay? So, I know that this line is going to be solid, that we have to shade above, and it's a y equals graph, so that's a horizontal line. Okay? So I'm going to draw that line right away and know that I can shade anything above that. Now, 8x plus 2y is greater than 10, or is less than 10. Subtract the 8x to the other side. We get 2y is less than -8x plus 10. Divide by 2. And then we get y is less than -4x plus 5. So our slope is -4/1. The starting point is 0, 5. It is a dotted line, and we shade below. And I'm getting all of that information just by looking at that symbol. Okay? So there's -5. I go down 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay? 1, 2, 3, 4 over 1. There's our line. And now we have to shade everything to the that is less than that. The only thing that meets both of those areas is going to be right in here. Okay? So that's it for, what unit are we on? Unit 5, 8, and 9. 5B and 9. If you have any extra questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, that's it. Good luck, guys, with the evens.